we did last year in September, wasn't it? In the Reading staff.
Yes.
Oh yeah,
Yeah.
So it's a continuation of that. This has been obviously an ongoing project for Network Rail. I sit within supply chain operations. We're responsible for purchasing all the materials for track mules and for the maintainer, and other projects may choose to come via our route to purchase the sleepers, the ballast, the rail, the S&C, to then us to load it onto trains and then to deliver it to sites. That's part of our sort of background and where we are. Previously, I was with Technical Authority in Milton Keynes, the sort of central engineering head office for track, and dealing with a similar subject, sleepers, went on to ballast eventually as well. And the sustainability, I guess, improvements and our targets started probably around 2022, 23. So we're in the sort of second year of that now, so we've sort of seen that shift. But I'm going to just take you through some of the changes from last year and some of the improvements and things we've introduced. You'll probably find some of this familiar, but hopefully it has moved on. So I'm going to take you through our hardwood sleeper cessation for changing for composite sleepers, some new sleeper development work, a bit on life cycle assessment and carbon reduction in sleepers, and also a bit on lateral resistance testing that we've done to prove some theories, and also the introduction of recycled blended ballast as well. So back in June 24, not far ago, we actually ceased the procurement of hardwood sleepers. So our hardwood sleepers were being procured from Brazil, not a great place, what with COP26 and all the other issues going on with sustainability, deforestation. Our sustainability team and within Technical Authority and supply chain operations decided to look at alternatives to timber. So it's your standard tropical hardwood timbers that we're purchasing. So this doesn't include S&C hardwood bearers, it's just sleepers, of which we purchase around, at that time we were purchasing around 50,000 a year. In some cases it was more than that in some areas because they were purchased them outside of the sort of Network Rail direct purchasing chain. So we did allow the ones previously ordered to be installed. You know, we're not going to go and rip out the old timber and put composite in. You know, this is just those that are being procured and installed from June 24. If certain yards or projects had a big pile of sleepers of timber, obviously they would still install that. But this is just for future provision. So S&C hardwood bearers are not included in this. Adjustment switches and gathering panels, all those sort of obscure fabricated panels that we make out of timber, they're still being made out of timber. This is just for sleepers. We have a standard TRK 2102 design and construction of track. There are lots of restrictions of where you can put sleepers, what type, what speed, what tonnage. We've got no change to that. Where it's timber, it's composite, and it already includes composite sleepers within that standard, so there's already provision for it. We do have an emergency stock just in case things go wrong, and we did run down stock as well, but we have an available stock. If there's an absolute necessity for it, then we've got that available. And this is the bulletin that went around. So we gave in October 23, so 6 to 9 months before, we gave people basically heads up, we're about to stop procurement. We went to ALG, different asset leadership groups and discipline leadership groups, review groups, to take it through them. We went to ELT, which is the executive leadership team, and they also look at sustainability. So we went through that as well, and we got Andrew Haynes buy-in, and that's how that basically progressed. So just a summary of the impact. The improvement in sustainability is 83% less CO2, so it's using recycled plastic in place of timber. 100% longer life, they do last twice as long. An average timber sleeper nowadays only lasts around 25-30 years. A long time ago, they used to last a lot longer because they were better quality, deforestation, they probably remained as a tree for more than 150 years and not the less than 100 years that they are now. So now they're a lot greener, a lot more spring to them, and moisture affects them, so they don't last as long as they used to. So reduction in deforestation, and we made a pact, if you like, with the UK government to stop that. So this is helping towards that as well. And that's by 2030. So they will have done their bit. There is the whole life cost saving, and that's through the extended life. So doubling the life, you'll get a whole life cost saving compared to sleeping. You won't see all that in our CP7, this 5-year control period. You'll see that in CP 9, 10, 11, 12, and further down the line. People wanted to see, what am I going to get in the next 5 years? We said, there is something, but you won't get it just yet. So, because sadly, we only do look 5 years ahead. But we make people aware, you've got to look way beyond that. Recycled material is UK domestic plastic waste. As you probably know, we've done some presentations on the Cycle material before, and I've got a little slide on the circular life later as well. Fully recyclable at the end, so we can take them back, melt them down, put them back through the machine and make them again. So, the quality of supply, we've got more assurance of the quality of supply of a composite sleeper than we have on timber. A higher specification compared to hardwood over the last 5 years, where we've seen so much variability in size and other things like warping, twisting, rotting that we get from timbers as well. Social values this is coming from the UK. It's UK domestic waste, it's UK supplied, it's UK manufactured, it's a UK trade, whereas we were coming from Brazil before via various different countries. So that's another social value there as well. So this is the circular loop. You've probably seen this before on how plastic will be turned into sleepers, plastic sleepers. They go in the track. Once they come out of the track, they can be used again. This is another example of repurposing on a bridge. So they were used for the retaining wall. Sleepers used for the side of the retaining wall instead of using timber. Then they can be melted back down again and reused again. Whereas you go into milk bottles, and milk bottles go around after, say, it's a short cycle of 2 months. This is a long cycle of, say, 50 years. So you're embodying carbon and plastic for a longer cycle, rather than the short cycle that needs a lot of machinery, a lot of CO2, a lot of processing to create it into what it was originally intended for. And after a while, the strength of those plastics does start to deteriorate, and you've got to start again with virgin. So you always mix the slight percentage of virgin versus the recycled as well. So that's the circular economy principle that Cycut sleepers, and there are other composite sleepers that we're looking at as well that have recycled plastic. Not all composite sleepers have that recyclable or use recycled plastic. Some may be recycled at the end, and you can churn them back in, but they may not contain a recycled plastic to start with. So we have to assess that, because we base this on a recycled plastic that's come from domestic waste, and that's the circularity improvement we've got. So if we were to change this product for another product, we've got to assess that change again, because circularity is important, as well as the carbon savings as well. A couple of pictures. It's a little lag. So someone, I think it was Lambista. Any of you guys been there? Yeah. So this was a spot replacement site. They took the timbers out. In fact, it looked like a couple of still left in there. Bulkhead rail, bulkhead chairs. Not much ballast there, really, is there? Vacuum ballast, just dirt, you know. But I think this is testament to, well, actually, whatever you put it on, these things can go into concrete under dirt. You know, they're not prone to split like timber is. And this site did flood afterwards. I wonder why. Is there anywhere for that water to flood to actually drain to? No. So this site actually flooded. During the installation, it flooded as well. So it was like, well, and it was holding up. The track was still holding up with the composites in there. And eventually, I'll come back obviously and do the other one. So I think it was a 1 in 3, but then they found a couple more extra they had to do as well. So and they used machines. You see the machine up the end there with the grab to twist and put the sleepers in. And these were pre-chaired. In some cases, we take one chair off, because you know what bullets are like to install, if you remember that, and how you put the chair in, because you have to sort of twist the chair up and bring the slide in and screw them on. So not as easy as our roll, as fast clip or pan roll, because bullet chairs to twist around the web. So that was the track refurbishment trial. We did some guardrail sleeper trials at Sherrington. So yeah, well, Sherrington's over towards Salisbury way, isn't it? Sherrington Viaduct. So there's guardrail sleepers with guardrail base plates, vertical guardrail base plates. That was 120 metres long. That's one of our longest renewals at the time. We went out, we actually monitored these sites, we were measuring the gauge, making sure everything was settling in. And that was so about a year and a half ago, installed by, I think, by Colas. So check rail sleepers, so check rail panels. We still use a lot of timber for check rail. We've got concrete variants, but this is a cheap alternative using composite rather than concrete. The concrete is more expensive the way they manufacture it for check rail sleepers. So that was on the back of some S&C. So we have S&C suppliers making these panels. We also have a fabrication yard that the supplier has to make chairs and base plated sleepers.
Have you done any pull-out tests of the bolts in comparison to wood?
Yes, we have. Yeah. So an AS chair screw, pull out on timber. The requirement is 30 kilonewtons, so the standard for composite is 30 kilonewtons. We get around 45, 50, 55 on side cut, so we get a lot more than we need. With timber, you may not get 30, you get around 25 to 30. You can in some cases, but with this, it's consistent over life. Depot in Askern, Doncaster way, and they'll drill all the holes to the base plates. You can have them fully blank, but 3 drilled one in, 3 drilled row ends, or drilled with base plates. So they try and do everything. In some cases, you may want to adjust the gauge on site, so you want to get pre-drill one side, and then you gauge the other side of the site because you've got various gauge. Some ask for that, some say I want blank, some say I want it base plated. So we do need counter boring in this. When we drill, we do have a counter bore because timber does split without a counter bore, because the shank of an AS screw is like that, it's bigger than the hole that it goes in. You're wedging it in, you're driving it down, and it starts to split. And we found quite a few timbers starts to split where you've got short ends, some panels, or you've got some cracks there to start with, and they just go bigger and bigger. So we do need to counter bore. That one left is Shiplake Viaduct. So quite a few of you might know Shiplake Viaduct and probably walked over it actually. So that was installed August last year. It's a adjustment switch panel. It's just off of Lashbrook Viaduct, I think it's called. You've got Shiplake Thames and you've got Lashbrook, and then you've got the Shiplake station there. So this is Walgrave side. I chose that site not just because it was close to my home, and it was quite an easy site visit on a Saturday, but because we were looking for a track renewal at a certain speed, of a certain line that they were doing, and Colas said, yep, actually we've done Sherrington, we're happy to help, change these. So that was a trial site for us. I think that might be Barmouth, is that? I think it is. And we looked at some new fixings for guardrail fixings as well, which are then rail foot clamps, rather than using. Remember, we used to put spikes in and just spike straight in on a guardrail, and the head of the chair screw had to somehow prise itself against the foot of the rail. we thought that's a bit hit and miss. You've got to drill them, and so using the rail foot clamps and a spring washer gives you a bit more hold on as well. We've recently introduced a document for sleeper guidance, and some of the composite sleeper information has gone in there as well to provide more people, or provide the users with guidance on where you can use them in place of timber, what the depths are, also how wide they are. We can go down to short ending to 250 mil off both ends if we're going to some tunnels, so they can go down to that. Not advised, but you know, worst case. All base plate types work, SSH screws and AS screws work. Rail spikes are not permitted to be used. So that is an issue where we've got the old RS1 base plates, because then they have to change the base plate. But we're also trying to make rail spikes obsolete in a lot of the branch lines. So it's a bit difficult. There's a cost there because they have to change the base plate. But we're trying to sort of remove spikes from the railway, and this is another way of doing it, if you like. Weight similar to timber, density of 840 kilograms per metre cubed. Wherever we've got a weight, depth or length restricted site, they're good for that. And this is one example. Concrete would have fitted in there, but it's a check rail site, and they wanted to lift them in, and they had a gantry crane that they were using, so it lent itself to that methodology. So just going on some other developments in composite. Don't know if any of you went to Rail Live this year. Did anyone make an appearance? Richard, you did, didn't you? Yeah. And the PWI stand was there in full flow. But this sleeper here, which is called the Hedgehog sleeper, or the Lankhorst integrated composite sleeper, did have its first show. It was CRSA, project led by Nick Matthews. It was assisted to start with by ourselves, the technical authority, and Jamie Wilkes as well, with some input from SEO and supply chain. And we were looking at creating a sleeper that has an integrated fastening, so the similar to concrete, the housings are inside the plastic sleeper. Otherwise, the other example is like a blank timber, if you like, composite sleeper with base plate screwed in. But we wanted to go near the sort of concrete design of integration that reduces CO2 for the casting of the base plate. You don't need screws to hold it down, and you've got the fastenings integrated, the housings integrated as you would with the concrete sleeper. So a company called Lankhorst, who are KLP. KLP are a steel manufacturer, steel wire, and they coat their wire in plastic. So it's the plastic, the recycled plastic they use to coat their wire. This has got wire in it. It's 4 reinforcing tendons that go in there. That are sort of spaced in the central section there. And then you've got the shape. And the shape is very odd. If you look at, that's the end. I think someone explained, I think it's Nick Matthews said it looks like hedgehogs nestling under the rail or something. And that's why they called it a hedgehog. But it's got also, if you look at it in certain angles, there are all sorts of animals in there. I think one of them was a wildebeest, if you looked at it from the end. But there are all sorts of, a dragon maybe, you know. But they called it the hedgehog, and in fact on London Underground we had a hedgehog sleeper, which was the old one with the reinforcing bars coming out. So, but I think they're trying to reinvent the hedgehog sleeper for this. So there you go. Those fins and the way it swages down is there for lateral resistance, so it holds itself in the ballast. So it's got increased lateral stability. It's been tested to be as good as a G44 concrete sleeper laterally. Balance sleeper, reduced balance maintenance. Yeah, that probably needs to be, I'd say, confirmed, but it's going to be installed in the trial so they can look at a lot of these ballast interactions, how we can tamp it. It's already been discussed about stone blowing. You know, is it stone blowable? I think the answer there is possibly not, but do we need to stone blow it if it's that stable? You know, so there's those arguments going through. It does fit a 3rd rail and 4th rail conductor rail port. You see the 4 holes there, we can put pots on there, so that was part of the design, similar to an EG47. and there's the drawing there. If you flip it on its top, and you can see underneath, it's actually latticed. So you've got all that hollow work underneath as well. So there's a lot of plastic saving in there, and you've got the tendon rods in there as well. So yeah, very interesting looking skeletal design. So yeah, currently undergoing dynamic and fastening tests and so on. Some of those have been done and completed. I'm not that close to the project anymore. I started with it, but I've sort of moved on. They are about to go, I think in the next 6 months, they should have a trial site going in and installing 100 or 200 of these and looking at that in situ.
Would they be suitable for any speed? Or?
That's another very good question. You're coming out on them all today. So we do look at composites at certain track categories. We say, okay, we want a sleeper that works for category 3 to 6, 20 miles an hour. We want a sleeper that does everything. A sleeper that does everything isn't the most cost effective because you might be high specking for 125 miles an hour, but you don't need it on the branch lines at 60. So we've got this view about, okay, we don't want too many sleepers, but it'd be good to have a sleeper that's good for high speed and a sleeper that's good for your lower branch lines, lower use, Cat 3, track category 3 type approvals. So that one is actually being designed, and whether they'll test it at 125 miles an hour, but that is the spec, is to go up to 125 miles an hour testing. They probably won't start at that when they first install it. The sad thing is that we can only really do fatigue testing using a dynamic rig, and we set it to the dynamic, the K value, which is the speed, and then the weight, and that affects the weight, and the weight goes up because of the dynamic speed. It's an EM test standard that we use. So we do increase the weight to allow for speed and tonnage, but it's not like a real test. You need to also do it for something like 10 million cycles as well to get a good idea. So it's going to be installed for 18 months and then trial and tested to see ballast settlement, geometry, gauge, all things you'd expect from a sleeper. Super elevation, making sure nothing's moved there, ballast hasn't migrated and moved around the weird shape. So we want to do it on canted curves, we want to do it on certain areas. And its aim is really to replace concrete sleepers up to 125 miles an hour. Now, we've also got another remit, which is we're getting some high speed on some of our track up to 140 miles an hour, so we need a sleeper for that. And HS2 might be thinking, we need some sleepers for higher speed as well. What are we going to use for that? So there is some common thought there, and certainly with HS1 as well, about where we go with sleepers and sleeper designs for high speed.
Just on that one, Darren, because that's a new sleeper development, and you're looking at putting USPs in.
Yes.
Now, are you testing this new sleeper for lateral resistance as well? So that, and when I say, is it better than the typical concrete sleeper you're using at the moment? You won't need to have USPs on it, because obviously it'd be difficult to fit them onto that if that's required.
Yeah, that's another one as well. So it has been laterally tested. They put it in the rig at Southampton. I'll show you the rig later, what we've done. It has a similar lateral resistance to a G44 with a USP, so which is like 12.5 kilonewtons, something like that. So it's got very good lateral resistance. Some sleepers we've looked at to add a USP, an undersleeper pad, to increase the lateral resistance. It doesn't increase it all the time when you've got voiding, but it increases it most of the time once you're in contact. But this doesn't need a USP because it's not stiff and stiff like concrete. You know, there is a bit of give there. There is a bit of resilience in there as well. So we don't need an undersleeper pad to protect the ballast. In fact, the ballast support areas and how the ballast interlocks in those holes as well is a lot different to concrete. You don't get that very small surface contact area with angular ballast. So it does protect the ballast better than most, as all composites do. And timber did, because timber used to embed. You know, we used to sort of tip up the sleeper and see the holes where the ballast used to be sort of, settled in. So some USPs, some composite sleepers we've looked at putting USPs because they need to increase the lateral resistance, but not the ballast protection. So, but this one doesn't need a USP.
Darren, is that going to cost a lot more to produce a sleeper like that?
So, it is more than concrete. We've got some figures. I don't think it's around, I think, looking at the last figures, 20% more than concrete, 25% more. 30, yeah, 25 to 30% more than concrete. So they are more expensive than concrete, but once volumes go up, and also we're knowing that these materials are on a scale of increase in materials at a lower scale, a lower, I guess, projection rate than concrete and steel is. So yes, it'll be affected by steel a bit, but not plastic, but concrete and cement and things, they're going up at a steady rate of 20%, whereas this. So you might find in 5 years' time that they're about the same. But it's something we've looked at, you know, it's with the supplier as well, and it's giving the, I guess, the customer an option. There's concrete, there's this. Some routes said we want to go ultra sustainable, but obviously we want performance and safety to go with it, without a doubt. But and some are saying actually we're quite happy to stick with concrete. And it's a similar debate about undersleeper pads. They add on £20 to a sleeper. Is it worth it in the long run? So we try and provide reasoning for it, justification why you should be using undersleeper pads, where you should be using these, you know, so that people can see in certain track mules and designs the best sleepers to use. But certainly where you've got lightweight structures, you want to put a sleeper down that hasn't, you know, there's no base plate there, so all you've got is the height of the sleeper, which I believe, I've got to read this here now, is it 140 something like that, so I'll have to zoom in on that, but yeah, maybe 150. Yeah, I can see it's blurry. Yeah. It's not just our glasses. But yeah, it's shallow construction depth, so it's less ballast to dig out, and we all know that, the savings that are there.
So you think you could keep in the same similar sleeper spacing to what?
Yeah, same sleeper spacing, and a plant and yellow plant, and ballast cleaning, and we'd like to do some ballast cleaning tests because trying to ballast clean that, maybe some ballast will start ripping underneath because, you know, you've got ballast held in there, tamping, stone and blowing, so there's all those sort of things we need to do. And we'd like to put it through a track lane machines, you know, does that work? Do they go down, do they skid around? Yeah, you understand.
Was this design initiated by this firm I've never heard of?
So this design, we set up a design contract to go off and design a composite sleeper. So we wrote the specification, wrote the remit, went out to all of the different composite suppliers. We didn't say what the shape was. We just said it's got to have fast clip housings, it's got to be this sort of size, this sort of depth, have pots on there as well so it can replicate an EG47 for southern. You know, don't want to leave out southern for the third rail. Maybe like the London would like it for the fourth rail with for the middle pot as well. So that was the remit, and there were some other standards and specifications that we use for composites and so on. And that's how it came. The shape came by we want a lateral resistance of X amount, and to achieve that, that's what they went for. Now they could have just said, actually we can achieve it at this with a sort of very similar shape. I'll show you some other sleepers that we've got at the moment. There's concrete versions of this, but they just thought, actually no, it's material saving. It was also based on another sleeper that they did previously. I don't know if there was a photo back here. Yeah, okay. See this one here? That's one they'd done about 5 years ago. This was Landcourse that did this 5 years ago. This is the 102. And it's got lateral resistance, it's got ballast scalloping, so it embeds into the ballast, and so it's a similar thing. It just didn't have the integrated housings in there. That you could put base plates on, certain size base plates. So it was sort of based on that. So they had the theory from that, they had the modelling, and I'd say it grew from that. They started taking away bits, and lo and behold, the hedgehog was born.
Is there not a risk with doing this that, although concrete you say is going up at this sort of level, it'll become, because everyone's being pushed towards plastic and recycling.
Do we run out of plastic?
There'll be a shortage, and then there'll be a premium, and then that will start ramping up and become really expensive.
And that is the thing. So a lot of these companies are looking at the commodity market for recycled plastics, and they're looking at how they're going up, because they have to buy them off of the Grundlands, off of the recycling companies as granules, and they put them into their mixes and stuff. You know, this side-cut product is UK waste. I think that's from the Netherlands, from the KLP product. It's from the Netherlands. It's waste from the Netherlands, and they've all got different rates for what they buy in plastic, recycled plastic. But if everyone starts using more recycled plastic, you're right, that rate there is in danger of going up as well. At the moment, they say it's quite stable. But what they're also trying to do is, some people are trying to link into a circular loop with a certain manufacturer, like Unilever or any plastic container, and say, can we have your plastic when you finish it? When it comes back, you know, if there is a way of it coming back, can we have it? You know? So they're trying to sort of do that to try and secure the market. But a lot of those things in the future, like you know, cement's going up and aggregates, quarrying restrictions nowadays as well, that we'll go into a little bit about later, but that's also causing us to think we need more recycled materials and things. We've got to reuse what we've got because things are getting too expensive. Just a quick 2 other versions. I was in a trans last week in Berlin and sort of stumbled upon the Voslo engineered polymer sleeper. Now, that Voslo have had this in production or development for I think 2 or 3 years. I think they've got some testing in track, and they've done a lot of testing. They've got a lot of data with it. They've now integrated housing in the same as the other product has done, Lankhorst. And also SciCut now, I don't know if they've tested this. I think it's just a display model. It's just flat, there's no inclination on there. But they're also looking at, you know, the big thing for composites and integrating housings is the stiffness in the rail seat area, the bending, making sure that the clip holds the rail doesn't start twisting around, so you've got to look at that fastening resilience, torsional resilience, and all the bending going on there. You've got obviously the rest of the bearer to think about, but you've got to think about now you've got a complete different rail seat material that you're using. So yeah, the market has opened up, and it was I guess in some way due to us putting out that tender in the first instance to say we really like this, and so people said actually yeah, we may try and go off and develop something like that. So it's good that it's emerging.
So just go back to the transport,
yeah,
because you just
sorry, Malcolm.
You looked at those particular ones. Did you go to the stand that had got? They'd taken a sleeper out that had been in for something like about 5 or 6 years.
Was that Getzner?
No. Yeah.
Yes.
Right, yeah.
And it was vertically, yeah, and it showed the undersleeper pad still there.
Yeah.
Yeah, it was 30 years, wasn't it? Sleeper.
Yeah, that's something like that.
Yeah.
Yes, it was.
Yeah.
Well,
yeah.
when it had gone through, you know, a huge number of cycles, really,
yes.
traffic over it.
Yeah.
If you'd have taken a wood sleeper out, or in the same sort of conditions, there would have been all sorts of.
You would have saw some weird things in the bottom.
Yeah, there was virtually no sleeper gull or anything like that.
No abrasion. No. It did have an undersleeper pad on. So that sleeper had an undersleeper. So it's not only protecting the ballast, it's also protecting the sleeper. So there's a lot to be said for undersleeper pads on concrete. And we're not ruling out concrete. In fact, that's what I was just about to drop onto now is the famous Cemex Rochester plant that Richard, you went to, Jeremy, you went to. So I was there again yesterday playing around with, well, they were, not me, but Cemex have been developing new shapes, new profiles for lower carbon, better lateral resistance by more vertical faces to lock, saving in quantities, you know, weight and so on. So this is sort of their, I guess, their concept stages of different Toblerone type ones, and you know, you've got castellated type ones, ones with dropped ends. You can't see that one very well, but the end has got a swage in it as well. All with the idea of maximising the interface with the ballast. They're maintaining the same soffit footprint, so that the same contact pressure is there in the ballast. These do use undersleeper pads as well, and they'll probably say actually we'll have an undersleeper pad with this. They're also looking at another solution to integrate an undersleeper pad as part of the you know, rather than stick it on afterwards, but have it as part of the sleeper. So they are at the moment they are doing some bend tests. They're looking at how it cracks, how so they do their first crack test, which you saw the machine, so they're testing a few of those, and we're going to send some off to Southampton to do some lateral testing as well. But whilst this mix and this design is sort of open for for change, they're looking at fibre reinforcement and other things. The steel rods, changing them to a fibre, or there's basalt, there's fibre, there's all sorts of different materials that are being considered for the steel rodding, instead of tendon wires that go through there at the moment. Recycled aggregates, so using aggregates from ballast or crushed sleepers, so they're looking at crushing sleepers at the end of it and using the stone and from that, recycling the housings, recycling tendon rods. Look at tendon rods and actually go, actually, can we use those? They're not, there's nothing wrong with them. Let's put them back into the mix. So they're doing a lot of things where they're looking at sort of the recyclability of sleepers at the end of life as well. So instead of, there's a lot of repurposing, or they just go into waste and crushed into sort of fill, type 2 fill and different types of fill. So they're looking at that. We spoke last time about some of the work streams we've got about new sleepers, and we have a specification for new sleeper technology. It hasn't really moved on, it's still in its draft form. Hope to get it out this year. We haven't had a tender where we've needed it, but there's certain clauses in there that are very useful for us for when we're looking at new sleeper designs. And we've got quite a lot in there about usability as well, and how we should be using sleepers. It's not just if it's concrete it needs to perform this way, it's all the other business requirements that it talks about. And we also issued the sleeper selection guidance, and that was in June, so that talks about all the different sleepers we have and where best to use them, and introduces composite and a bit of concrete and all different types of concrete as well. Within the sleeper guidance, you remember this chart that we had before, we've updated this, and we had to make sure this was airtight. We had to redact some of these before, but now this document is a document for everyone to see, anyone can get hold of it. There's prices on there, and there's CO2 on there, there's whole life information on there, there's a lot of information on there. And that's what we buy the sleepers at and what we sell the sleepers at, and that's the carbon rates there as well for all of those. Where we've highlighted them in green and red, that's sort of green is where they're preferred. So if you see lots of greens along there, that's a good one. If you start to see some reds and ambers, then it's starting to deteriorate. But lateral resistance, ballast and geometry, stiffness, durability. Then at the end we've got the CO2. So we've got the CO2 for the sleeper. We've also added the serviceable sleepers. So when we've got sleepers that come out of track and we cascade them and make them serviceable for different track categories as well, which is good value for carbon because we're reusing, and they're half the price. And you wonder why they're half the price, but yeah, it should be less than that. But it's more about logistics and moving around and transport and so on. And also the sort of typical tonnage that we use. We can actually use this table to adjust the tonnage. So if someone says, "Can you tell me what sleeper is best for 60 tons?" Then we can change that blue column, and we can look at different whole life cost savings and stuff like that. So that's been quite useful, but also been a headache for me because lots of people come back with lots of queries. Hence why it's got 15 notes on the bottom of it. So about our carbon savings, we did present this last year on the CO2 savings for hardwood, basically being stopped and replaced for composite. Still, there is a proposition for 2025 that the steel figure will reduce. It's British Steel's plan to do that. Whether we see that, but we hope to see that, is something that we're looking forward to. Now, concrete at the moment, last year it was at 60 when we first came, now it's at 52, so we're reducing it further and further. I think the average last year was 59 or 58, I think. We've now got it to 52 for 52 kilograms per sleeper, whereas in 2022 it was around the 100 mark. Then we started to play with different designs and recipes, and we got it down to 52 just this year. Composites also reduced because they've been doing some things internally with mixes recycled and other things as well. So they've reduced that down over the last 2 years. But the saving there is that it's a 40% reduction in CO2. So, I don't know if you can recall Andy Franklin doing a talk on buckling. I think it was in this room, wasn't it? Yeah, last year. And Andy and I were discussing certain things about track buckling and lateral resistance plates and why do we get track buckles, and other reasons behind that. So, in terms of what the sleeper does for lateral resistance, we wanted to understand what different types of sleepers provide in the way of lateral resistance. Not talking about spacing, we're talking about the actual sleeper, the weight, the size, the shape, the contours and so on. And what we wanted to do is also look at what would be the best shape for a sleeper that provides the best lateral resistance, so that in the future we've got a future-proof, resilient, climate-resilient sleeper that hopefully, the CRT value we use, we can increase it above what we do now. So we go above our 27s, our 30s to 35, we go up to something like 40 CRT, plus the other, something like, so until we get rail temperatures up to 50, 55 degrees, we know we've got a safe track. And this is what this work was aiming to do. We're also looking at what does a lateral and resistant plate add in terms of lateral resistance. What does that add to the mix? Are we adding 50% or 30%? I think we went over some of this before, and I'll show you some of the results. I showed you the sort of rig at Southampton. They're still using the rig. Other sleeper suppliers are putting sleepers through it. We've had some composites recently. We've got undersleeper pads. They're about to do some ballast glue trials to see what ballast gluing adds to lateral resistance as well, to see if it's better than LERPs. I mean, over time, it's difficult because ballast glue sort of deteriorates, isn't it? But it's it's just looking at what can it provide from the start. So it's been a good use of their lab and Southampton's facility to do that. And we looked at all the different ballast compaction rates and sleeper types and profiles and so on. If any of you are going to, in fact, Southampton University would be a very good visit.
Oh,
it's not too far to get to, is it? So that could be another potential visit.
Yes, we can imagine that down.
So here's the output from the G44 without a USP as the blue one. So that's sort of like a baseline, somewhere around 8 kilonewtons. And we look at these in 3 values, these charts. We look at it as an unhooking value, which starts to move, which is around sort of 2 to 3 mark. We look at the average of around between, I think it's 25 and 30 average, when it's moved and it's getting towards that sort of half head width. And then we look at the maximum as well. So by adding a USP, so G44 with a USP, don't worry about type 1, type 2, they were just trying to find a different type. But if you look at this green or the black mark there, we've increased it by about 3 or 4 kilonewtons, 4 kilonewtons. So we've gone from something like 8 up to around 12. So it's added on a good 30% there to what we had in the first instance. Now you can see the LERP is very similar. So the LERP is that beige line that doesn't come out very well, but it's following the line of that black one. It's in between the green and black. So a LERP and a USP are offering similar lateral resistance. That's what we found there. And the query then was, can we relax the use of lateral resistance plates in our track installation, because they cost a lot of money and they're time to install, and you have to pull them up when you want to tamp and those sort of things. So, and that was a challenge for the business, because they said, can we relax LERPs because it's costing the business a lot of money. So we proved this, but we haven't won the fight over changing the standard. I think for that we need some more in situ tests and trials and just to improve it. And don't forget as well, I mean, this is, undersleeper pads, if we get a void in there, like any track, if you get a void, then it's going to move. So an undersleeper pad isn't going to help you there, is it? So there is that analogy, but we do allow for that in our standards, the voiding. When we say track is voiding, we minus the CRT value anyway. So here's just a summary of all the different types we did: G44s, EG47s, with or without USPs. We did a Stanton Bonner twin block, what they use in HS1, high speed, and they use in France. Quite high lateral resistance because it's 2 blocks, 2 faces, well 4 faces if you like, with a bar. So you've got a lot of ballast locking with it with the twin block sleeper. Timber, that's probably our lowest, and then side cut sleeper is quite low. It's only just above it at 5.79 above timber, so it's not. The deeper one, as you get deeper, you get more anchorage, you get more ballast pressure, so you get 7.15. So you are getting better, you get somewhere similar to an EG47. And then there's a steel sleeper there as well. Steel sleepers are actually quite good in terms of lateral resistance because they dig in and they've got spades that dig in. So. British Steel have done some more testing on that as well. I won't go into that trial. So that's our lateral resistance trials. Still the debate about changing standards and so on, but it's been very useful for us to get some figures. So whilst we were doing the ballast side with Southampton, another project was looking at recycled ballast or recycled blended ballast. And what testing or what approvals or evidence do we need to show that recycled ballast is fit for purpose, can be used, and we're not going to have any issues with it? Now, yes, we've been doing it for 50 years with ballast cleaners, so we needed a bit more evidence than that. But if ballast cleaning using a similar thing but on the rails is acceptable, and we've never had issue with ballast cleaned, and unless we get a lot of, the return is different, but we are also mixing new and old with the ballast, and sometimes we do 50-50, 60-40, new ballast and recycled ballast. We wanted to see and do get the science behind it. What is it with recycled ballast? With the spoil that comes out, we take it away and we do some processing and then we put it back in. Is it as good as normal ballast? And our aim really is, and this is about circularity, do the trap renewal, ballast comes out, we sieve it and wash it, and then we put it back through. So it's just making it circular throughout its life, and we can keep on making that circular and circling it around. So the intention was that all future supplied ballast will include an element of recycled ballast blended with new. So maybe 20% recycled with 80% new, or 75-20. As feedstock gets more, we have more ballast, more spoil, more sites that can do this, then we'll get a higher increase. It could potentially get up to 50-50, but it's putting that element back of recycled ballast back into new ballast. So it wasn't just about carbon savings for this. This is a sort of circular economy. It's a bit of a myth buster about what is a true circular economy. And sustainability team put this slide together to say one example of a circular economy is this recycled ballast project. So it sort of explains that just here, trap ballast is made up of large aggregates, mainly granite, a raw material which is extracted from pits and quarries in the UK. Quarry operation is energy intensive and the process affects the local ecology by polluting nearby watercourses. So it's a biodiversity issue. You get a loss of biodiversity, and also a lot of quarries are now finding it difficult to extend their licences because they've got to be a lot more nature friendly and biodiverse. So we carried out these trials and looked at the 50-50 blends, all different blends, and this they thought was a good example of circularity. And looking at sort of, the amount of savings we could get by reusing spent ballast in CP7 as a whole. So it could be a 2 million tonne saving, and the UK natural mineral resources and business 7,000 tonnes of CO2. So that's quite a lot of CO2 saving. Most of that, what we're looking at, it's not just about CO2, it's about the natural depletion of quarries, and minerals in quarries. So that's the main reason for us doing this.
What about the actual recycling of the of your recovered ballast? I mean, that it's a perfectly viable way of doing the thing, but you've still got to either sieve or, more importantly, probably washing the
Yes.
The ballast you've produced. And then you've got to have a process of being able to mix it with the new ballast as well.
Absolutely.
You just increase, you're
got
putting in
processes.
lots of extra costs and things.
Right, so all you're really saving is the natural is blasting a quarry, blasting, breaking down, putting it into, and then the processing thereafter. So that's all you're saving. Here, what you're having to do is you're transporting it back from the vehicle, you're putting it through a wash plant that you're going to see a video for actually in a minute. So you put it through a wash plant, take out all the other stuff, and take out all of the other materials in there that should be in there, which you'll see. And then you have got that processing cost and processing CO2, if you like, for the mechanics.
Environmental bit as well. You get rid of the water.
That's right. And on an EPD, environmental product declaration, the quarrying and everything that does to the natural resources is still high in CO2 and obviously biodiversity issues compared to a lower CO2. But it's not about CO2 savings. This is more about circular materials, keeping it going. And it's not a big improvement on CO2. There's a 50% saving, but it's so small to start with. Granite ballast has got one of the lowest CO2 figures per tonne. It's something like 7.5 kilograms of CO2 per tonne of ballast. So it's not a lot.
Not going to make much more, are we?
can't get that much further down. So it's about saving its natural depletion, so 3 million tonnes a year from quarrying, 50% reduction in CO2. There is also, we do need to look at this in more detail, but some of the plants where we do have ballast from source does have a lot of fines in it, and it should have been removed, and we have issues about ballast dust and health issues as well. So from a health and safety point, washing it again does remove a lot of those fines. So even with new ballast, we've had to get new ballast in and wash new ballast just to remove the fines as well. So at least you're trying to manage the fines. Some of the sand that comes out of it, we use that for sand blankets. We've just got to look at and other sand uses of sand. Some of the smaller aggregates we're looking at using for sleeper manufacturing, so putting that back into sleeper as well. So not just the big 50mm lumps. And this pathway inflow as well. There's a sludge called a cake. That could be used for pathway inflow, and they're sort of looking at how they can use it. That's probably a byproduct, but they just haven't got a real good use for at the moment. But that's what the companies are trying to do.
Have you got a potential site in this area for ballast washing?
So there is a site. We've looked at 6 different suppliers of ballast. The site here that I'll show you is at Stoke-on-Trent. So it's quite high up, and it wouldn't serve us logistically well. If you were to look at our map down here, we've got Westbury Aggregate Handling Depot, AHD, and we've got some other AHDs. We've also got Aggregate Industries at Sheerness. Sorry, Isle of Grain. So there. So that's probably our nearest for south that will feed our stockpile. We've got to look at the logistics of. We've only got one at the moment, one approved. We want at least 3 approved, and we want them logistically placed so that they can serve all of our renewal hubs in the future. So some of the sort of risks and disbenefits of recycled ballast that we're looking at, and we wanted to sort of, I guess, try and prove and evidence to say why it is just as good as new ballast. Variability of quality, different sizes, different grains, different minerals, consistency of granular material, impurities from excavation material, so all the other impurities that we get that we can flush out, but is there something going to stay in there? What's going to stay in there that we can't detect? Loss of angularity is a big one that everyone talks about. Well, we've knocked the sides off it, you've knocked the corners off, you've got a nice smooth bit, but there's more to it than that. The particle roughness, so the friction between the 2 particles, the change in the shape. So if it was elongated before or was a certain shape that locked in, have we changed the shape now that's not as good for locking? How quick it degrades, breaks down, settles. How fast the ballast might migrate. It might migrate more and move more and expose more of the sleeper and sleeper ends. the strength of the ballast vertically and laterally, so track strength and the strength of the ballast to move sideways or vertically. The lateral bid stability of the track, that we're relying on ballast to sort of provide as well as a sleeper. Organic content, we get a lot of leaves and other bits in there that's organic. How much of that is allowable we can leave in. And then there's the limestone. So we did have limestone at a lot of our old sites that's still out there. We're still finding some limestone. We found about 3%, 2% on some of the samples. So it's still probably under, we've dug most of it out, but it's still in a lot of sites. So if we mix that with this ballast, what's the...
Darren, that's highly laudable. All this is absolutely fine. There is another part of Network Rail that have made a conscious decision to not do very much ballast needing in the future, which rather reduces the amount of...
And that's a good point. And we've actually said, why aren't we using this to get the high upper ballast cleaner back in? Yeah. And Peter Flynn, you probably know Peter Flynn from the high upper ballast cleaner. Peter and I have been saying why this is really good justification why we should be using more ballast cleaners, because recycled ballast is circularity, and we've proven through this testing I'll show you. I won't go into a lot of detail because we're probably running out of time, but we've proven that it does work. And so it's 50 years of track that's been ballast cleaned. This has proved it as well. But yeah. But and this Peter did say if we only had this like 3 or 4 years ago, when then that may have been another reason for hopefully extending the use of. Yeah, it's a shame. So we looked at doing tests on lateral strength, sleeper lateral resistance. We did some triaxial lab tests to look at the shear strengths, and dynamic loading to look at the settlement, vertical settlement. And we also did some independent testing against our own track standard, which talks about particle sizes and lengths, abrasion, micro Deval and Los Angeles, all these things that we use for ballast, for testing ballast. So we also did some petrograph analysis as well on that. There's our standards, 2102, 8100 is our railway ballast and stone blower aggregate. We're not using this for stone blower aggregate at the moment because it's a different type of, we're leaving that to one side. We don't think it's good enough, but it's something to test. At one point we're just doing railway ballast at the moment. Plus you won't get a lot of that smaller aggregate sizes from recycled ballast because it tends to be one way or the other. Use of ballast returned from auto ballast cleaner as well, so Euro 9 standard as well. And aggregates, the Ian standard aggregates from the railway industry. So back to Southampton. Yeah, we did some more tests, but this time we're testing the ballast to see what's the ballast doing, what's recycled ballast doing against new ballast. Are we still getting lateral resistance properties the same? So here is we've got recycled ballast, which is the red one. Synthetic ballast is a ballast we created that basically mimics worn ballast that's 30 years old, a lot of fines and clogged up, and we didn't go and dig a load of stuff out and put it in because the guys within the lab said, where's that come from? And health and safety and all those sort of things. So we had to create a synthetic ballast. This is with Southampton University. They looked at the particle size distribution and all those sort of things to make sure it sort of mimicked what they knew as a worn ballast, if you like, or used ballast.
So what was it made of? Saying synthetic ballast, what was it?
It's ballast, they call it, I don't know why they call it synthetic, because they basically try to mimic, it's still ballast, but what they did was they added fines into it. They added some fines, yeah. Rather than add dirt, or just mud, they said, okay, well, to mimic that, we're going to use some, and they called it synthetic. I said, well, yeah, they described it as synthetic, but it's actually a worn ballast, yeah, so I always have to explain that one. I might just change it, it'd be easier. Everyone goes, oh, well, I don't know what synthetic ballast is it composite ballast lumps? So you can see here the lateral resistance is better than for recycled. It is just as good as fresh ballast. Lots of different tests and different, this was loose ballast, so just thrown in. Then we did, is this the dense one? So yeah, dense, so this is compacted and then the sleeper push through as well. And you can see, it doesn't start right at the start, it's not as good, but then it starts to kick up and go over there as well. So you're earlier on down there, you get it, but you just hear it sort of So we're saying it's as good as. You know, I'm not saying it's miles better. For us, we look at that area there, we look at that unlocking, we look at the maximum as well. But you know, it's as good as. So we prove that the sleeper is going to not move any differently to new ballast. We then did some triaxial. So this is an interesting machine, the triaxial machine. It's 600mm diameter with a ram that's dynamically loaded, and it measures and it also adjusts the stress around the side by displacement and measures the displacement as well. These are radial belts that tighten up as the displacement goes, but it's measuring how much force it needs to bring it back into shape. So it's how it retains its column, if you like, in its size. So they did this test for 50-50 mixes, 100% recycled, 100% new, and got some results from that. And we also did some particle size distribution, so PSD, looking at the various different sieve sizes we have and the sort of range of sieve size. So that, if you like, is that dotted line there is where it should be. That is our upper and lower control limits as we go along for the percentage passing through the sieves. And you can see fresh ballast that we sampled fit nicely in there, so that's good. The 100% recycled didn't, it was outside, so it wasn't great. It had it's on the lower side of the sieve particle sizes, so it's pushed over that side. As we started to mix it, we started to come more into the 50-50, we started to come into those control limits. You can see 25% was good, so that's where we said, well, actually, a 50-50 mix is probably a good place to be. What interestingly, what Southampton did say was, are those limits right? Because for track ballast to perform, and we've shown it's performed, maybe better they are over that way more anyway. So there is a sort of a thought about how we got those limits right, and they're from EN standards and what we've been doing over the years. But if we're proving that performance of this type of ballast is better, then that could be questioned. But we're still, so from particle size distribution, mixing it 25-50%, we're bringing it within the bounds of tolerable. So we also cut some samples up to look at mineralogy, to look at what they've got, and they also looked in the bags and saw, oh, there's some granite, there's some basalt, there's some limestone. Not a lot of it, but they've just seen samples of that. There are bits of glass in there. Brick, brick did appear in there. A small bit of brick came in there. So how did that get in there? Because it's not as dense as this. So we need to understand why it got through the process. But looking at what they had, they're sort of most of that 63% was granite. It's quite basalt in there. 9% limestone. The other, they also did a sort of further analysis on as well, and then they did the full mineralogy check on the density. I think they did some diffraction, X-ray diffraction, and they found out what the quartz and feldspar and the types of minerals that were in there as well, just to see. Because you're looking at some samples where you don't get a lot of red and green, because that's your quartz and feldspar. If you get lots of blue and other bits, then it's not a good sign. So we just have to see overall what mineralogy is like as well.
I think on that, Darren, if I may, as far as ballast cleaning is concerned, over the years, I think it's pretty well accepted that the higher the return that you're getting on a ballast cleaning site, the quicker the track will consolidate.
Yeah.
It will become, its lateral stability will increase very quickly. And the one way of really increasing it very quickly and getting it to the state where you have a very stable track for a long period of time is to dynamic
DTS,
and if you do that at an early stage, 2 tamping cycles after the ballast cleaning will then make it that even on the highest traffic routes, you'll be 3 or 4 years before you need to dump again.
And
that keeps your voids out of the track,
yeah,
and it's
yeah.
the best way to get your lateral stability.
So we'll go back onto the axial test and verticals, the shear strength. We're finding these rock samples had a higher shear strength, they were stronger. That's basically because they've been work hardened. So all of the weak angles have been taken off. You're now left with a work hardened stone that's had all of its weakness and sides taken off, and this is what the ballast can. And then its ability to then lock with other stones and lock in place without moving is higher. So that's where you get better stability with recycled ballast than you do with new ballast. It's not just about angularity, you know, having those, because with angularity it's a very small point of contact which then rubs down eventually, but you've got a point. But the surface roughness is important to have those side deflections. So there's a mixture of roughness, angularity and size. Southampton have got an amazing piece on this and dissertation that the engineer that ran this has got about what makes the perfect ballast, and they looked at what they did in their 2011 paper and said, actually, no, this basically summarises and backs up our argument about roughness, angularity. And William Parry, who you probably all know as well, William was involved with this, and we were talking through William, and we sort of came to agreement. It just shows that the ballast is work hardened. It's had all the soft bits rubbed off, and you've got the hard bits still left. So a bit like work hardened steel, isn't it? Really, at the end of the day. So it's so in our figures we showed that the I haven't got all the graphs, but we showed that vertical stability was improved by 8% on this. So its ability to vertically, stay in place was better, and that's the same laterally as well. The porosity, so this was due to the density. It had increased density because it was locking together more, less apertures and voids, if you like. But that then has an effect on the porosity. So you'll obviously take a miss on the porosity. But we thought that 5 to 8% isn't a huge, big deal. I mean, what we're actually doing is we're taking away the likelihood of it breaking down in its new ballast going in and being DTS'd. You get fined straight away from that because you've aged it, haven't you? So we're taking away that aging effect by it already being work hardened. So you won't get the production fines is over a longer time with new ballast, well, with recycled ballast. I won't take you through the process. It's this is a recycling plant process. I've got a video to show you which I hope will work, but we're also trying to look at hazardous waste because we could actually at some point recycle hazardous waste. There's ways of dealing with the contaminants and the chemicals because we spend quite a lot of money a year getting rid of hazardous ballast. So there could be a way of us looking at that. That's the next phase of the project. But the process is basically stockpiling and mixing and so on. But I'll show you the video. I used that slide before I had the video. Just hope the video works. And so to the approval and summary for recycled ballast, it got approved in April. I think it was May in the end. We had this approved. Lateral resistance showed no worse. Ballast consolidation shows stiffness and springiness is no worse. And springiness is quite important as well to retain shape. Triaxial tests of different blends demonstrate strength and settlement are no worse. Abrasion tests better than new ballast. They're stronger. Had the PA approved as land recovery that deal with this, who've since been bought out by Aggregate Industries as soon as it's got approved. And compliance to TRK 8100. And there's a few small minor things there that it didn't comply to, but head of track himself and the TA Ben Lee that helped us and some other guys that helped us, we agreed that we need to change TRK 100 to allow recycled ballast to be part of our specification. So we found a few things, a few areas that it was silent on, but we did quite a bit of research. So we thought actually we could change our standards. So we've got full acceptance for supply of recycled ballast blend using a maximum of 75% recycled. So still got to be a 25% new ballast in there. So not that we're at that stage yet. We haven't got enough feedstock, but we're more 25 recycled, 75. And the big thing was QA, quality assurance process was needed to make sure we still get the particle size distribution, the abrasion tests and the fines tests that go with it, just to make sure that we're keeping them monitoring with the ballast as well. I'm going to see if this works. Might be a delay. Yeah. There was a little bit of delay between my laptop and there, but. So this is Longport Rail Terminal in Stoke. That's where all the spent ballast goes.
Is this a private company?
Yes, private company, yeah. We outsource this. We have aggregate suppliers that bring to our sites. We've got a lot of aggregate handling depot sites. But this is a private facility where they wash, process, all that. Yeah. They also circulate water as well, so it's not just fresh water all the time. They've got filter tanks and float tanks and. Yeah, so all the finer stuff and sludge that gets pushed to one side, but they still have use for some of that. That's the final cake. That's all. That's the byproduct we want to try and find a use for. All sorts of colours there, isn't there? Very diverse ballast mix. One thing they are doing with some of the separation of the impurities is they've got infrared detection, so they can ping in the infrared density scope at it to see if it's not the right density, and it zaps it off, blows it off if it's not. So it's a lot of money to invest in this. And there's some other pattern recognition stuff they're looking at as well. So various different suppliers are looking at how they can make it even better by taking out those impurities. And then they do the mixing.
Find any gold?
No. Pyrite, lots of that. He wants to go home. So, once they've mixed it, they go for another wash as well. So, because whilst you're mixing it, you create more dust and other particles whilst you're doing that. And they do a final wash of the blended.
Is that all for railway use or?
All for railway, yeah. That is our material, and they'll sell it back to us. Yeah. The costing thing it's cheaper than new ballast. New ballast is going up again because the material quarry cost has gone up. But, so we will save money from this process. But equally, they will make quite a lot of money.
So do they get this for nothing, or do they have to buy it?
We give it to them for nothing. Yeah, we provide it. The wagons come in straight from the trap mules. Yeah, I think they do hazardous waste there as well, and they do new ballast as well. Road sweepers. They've actually got, is it 14 Class 6 and 6 locos? About 200 wagons. They actually do a lot of ballast transportation as well in the networks.
You organise the trains?
So the trains coming in are just done through the usual network rail, dispatch. They've got their own locos if they need to. If they need to push out, or they're not having, but it's generally supply chain and network rails roll to arrange the trains and arrange the wagons and stuff. But they've also got the ability to say, well, if you want to use our trains and our wagons, there's an option there as well. So for additional flexibility. That's another part of the business I don't really get too much involved with, but in looking at potential suppliers, making sure they've got other ways and means of transporting stuff around as well. So we have an implementation plan. This will just sort of wrap up the ballast side. Our suppliers are providing us an update on their developments. So currently they're looking at the impurity detection, using pan recognition or infrared for density. And looking at they're revising their QA processes as well. So one supplier is approved, but there are other suppliers that we want to bring on board as well. QA team, our quality assurance team, is supplied to provide regular monitoring. So we've got regular monitoring to make sure we get the QA for this. Logistics plan, we need at least 3 aggregate handling depots for this for national coverage. Certainly one down south to manage this area, and then we've got one, I guess, in the Midlands and so on. The unit rate cost is expected to reduce once we get further supply strategies in place and it becomes a larger operation in terms of logistics and feedstock. The rate is lower than it is at the moment, but we expect it to get even greater as we increase the depots and the other sites. It will just be a single rate for ballast. You can't buy new ballast and recycle ballast, it's just ballast. So, and people won't know if it's 25, 75, 50, 50 in future, it will just be ballast. So, we're tracing it because we've asked them to trace how much actually goes into each one. If it's 25% new, 75%, we need to know on a certificate of conformity. So we are tracing it, but people won't have a choice, it's just going to be ballast. We're telling them, by the way, you're going to start to see some recycled ballast coming in. And that's an SEO sort of, I guess, strategy to do that. Limited stock, initiated some stockpiling, so we've got some spent ballast up at, and we have got it installed in sites, so we've got some sites, not on western, but we've got some eastern and southern. Site near Weymouth and sites near Doncaster have been installed with recycled ballast. And there's probably a few more since then that we've done. And we wanted to showcase it as part of our sort of low track carbon sustainable track. So eventually when we get the green rail and the recycled ballast and we get the best CO2 sleepers, then we've got that whole low carbon track. Yes, 6 ongoing discussions with 6 other ballast suppliers to see if they could do it, and even recyclers, so people that teamed up with ballast suppliers to look at the plant needed to do that washing and processing and stuff. We had discussions with Holland, ProRail. Some of them have been using it for over 7 years, 8 years. I think ProRail 2015, and they've got it in their standard. And we also need to update TRK 800. So that's ballast, and that's circularity in that sense. I've done sleepers and ballast, and I think that is it. Apologies, I've overrun slightly.
Yeah, that's a long 45 minutes.
Yeah, it was, wasn't it? But I did answer questions as we went.
Yeah.
No, we've got time for some questions, I guess, if there's anything else. Mike?
Yeah. The composite sleepers, how are they produced? Is it with heat or with glue or?
So the one you saw on there, the
hedgehog,
HDP, so the hedgehog one is in a mould. Yes, that's in a mould, and they inject the plastic and they have the tendons in there. And the plastic is recycled plastic with a filler, mix it up at a temperature so it'll be slightly warm, then pushed in. I think it's pressure moulded, because normally they are pressure moulded. The side-cut sleeper, which doesn't have any tendons, it's just the recycled plastic block, that's pressure moulded in at pressure, at temperature, and then into the mould itself. And that's using the recycled plastic pellets and a filler as well that goes in there, like bit of carbon black and some fibre filler, which binds it together. And then there's a big cake mixer. No. But it's yeah, and then it's baked basically.
It would be
Yeah.
more expensive to produce than concrete.
In concrete. So the energy, I'd say so.
Yeah.
We've never actually broken down the true costs for. We know what it is for concrete. We know the sort of, you know, the aggregate, the cement, the water, the plant and stuff. The plant's a lot smaller for plastic sleepers. It's not as big as a long line or a carousel system, so it's a lot more efficient in that sense.
Right.
But the materials are more expensive.
Yeah.
Yeah, and I'd say the equipment used. I've seen some Sekisui bearers being made. They're fibre reinforced with urethane, and they're sort of pull-truded through a rectangle that's the shape of the bearer. It comes out at 1.2 metres a minute or something, and it's just coming. It's just building's about 80 metres long, but it's just sort of coming out, and they just chop it. What length do you want? But it's chopping it as they move, obviously. But and that's a slightly different process, but it's very accurate, and it's all in the mix. And then once it gets to a certain heat, pressure, density, you know, then it starts to come through.
Okay.
But yeah.
There was a relaying train in East Leeds last weekend.
I was there.
Composite sleepers, yeah. With that 10 wagons of them.
Really?
Yeah.
Oh, you spotted that?
Yeah.
Yeah. They do, on Southern, they're doing quite a bit of plastic sleeper renewals, yeah. Because they've got a lot of bridges and they've got a lot of areas where they need them. Yeah. Ordinary.
I think you've explained why the original, the first pictures you showed, looked rather as though they were creosoted. Well, some of us are old enough to remember Hayes creosoting works.
Yes, yeah.
What came out, which smelt beautifully. But I think it must be the carbon black you said went in the mix.
Yes, yeah.
They look very dark.
Yeah, so the natural colour of one of the Psy-Cut plastic sleeper is a light grey colour. The carbon black does give its blackness, but it's also UV resistant, so it makes the plastic ultraviolet resistance. Because without that, like you see some insulators and other things, they start to lose their colour and they start to dry up and break and just fragment. So it needs some level of UV resistance because you've got the top layer of sleeper that's seeing, you know, sunlight all the time. But in fact, Roddy, you're right about the creosote. A lot of people do have that from memory, don't they? And fence panels and telegraph poles and those sort of things. But what started it in the first instance was the creosote ban the creosote ban lasted for years, and Network didn't really, or no one in the UK really bought into the legislation. It was really odd. I don't know why it happened, but we were supposed to, but we got away with it. So we said, actually, no, we will ban creosote, and so it's only for soft fixed sleepers we use creosote. Hardwood we don't. So we said, right, and that's when we started. We started this journey by banning softwood sleepers and using recycled plastic in the first instance, and then going on to the hardwoods. So it's a bit of a phased approach, but yeah. And there's even creosote alternatives now. So they come to us saying, "Oh, we've got a really good creosote alternative." We said, "Well, we haven't got any more softwood sleepers. We don't put creosote in the track. We put it on the start." So, but yeah. I think
it's Calders and Grandage
yes.
Were selling sleepers that had something else in them, a green sort of fluid.
Yeah.
Is that something that's a
Tantalin?
Tantalin,
Is that
a phase that's passed?
Tantalin was another alternative.
It doesn't go in very far, does it?
I don't think it penetrates as deep as creosote, but it was being considered as an alternative, because on London Underground we used to use a lot of creosote sleepers, and I remember that coming to because we had Calders and Greenwich and we had various other suppliers of timbers, and they did propose that because we said, look, we've got to at some point ban creosote, but what are the alternatives?
Did they ever use Creocoat because it was like a sort of oil based? It was a sort of fake creosote.
Yeah, I don't know where they got to in the end. I think it was just easier just to ban it because there was nothing that had the sort of the performance as creosote did. Yeah, or the smell.
I have still got half of it.
So that's a lot of the black market.
Can I ask?
Because I used to say that the creosote haze affected the complexion of a lot of the workers in this place.
Yeah, I bet. Yeah, and played with their heads.
A very simple question indeed. When a plastic sleeper's got to the end of its life, what condition is it actually? What's actually wrong with it?
So they can be assessed for serviceability to look at, is it still got its shape? Is it
Right.
is it bent? Is it warped?
Right.
And we've got in our standard for serviceability composites, we could do a measure. We say actually, yeah, it's still the same depth, and still the same width, and it hasn't curved or bent or shaped or deformed. Therefore, use it again. You know, the fact that we're doing a track renewal or putting something else in
So
to replace it,
when it's got to
can
the
be
end of
repurposed.
the life, it's
When it's completely
probably
unusable
yes.
and uncascadable, and
Right.
you've just got this plastic lump that it can go back to the
Yeah,
supplier.
but it's the wrong shape by that time.
Yeah.
Would the chair screws pull out easily? Would the holes become, enlarged
So
or something so
it-
they don't grip very
You
well
can
anymore?
you can still use grip fill. You still use
Yes.
spike fast type
Yes.
or resin to fix if you want to do the pushing through. If it's the holes that have just collapsed and you're not getting the screw fixed, then you can do that. But if it's then decided actually no, it's the end of its life, then it can go back to manufacturer and melt it back down.
Okay, but the main thing is it's become distorted in shape, so it's
Yeah.
not very satisfactory at the
Yeah,
line.
yeah. If it's, I think it's more than 10 millimeters over a meter, so it's
Right.
got to be about
Yes.
25 millimeter bow before it becomes,
Okay.
and
Yes.
yeah. But it's all about how you assess the serviceability, isn't it?
Yes.
Some people might say, I don't mind that.
It's all
I don't
right.
mind if I've got better inclination in my rail. So yeah, but yeah, it's in the serviceability standard on what's acceptable.
Talking of rail inclination, some of the photos, one of the photos from was it Germany?
In the Trans?
Yes, where there was that sleeper rail pad that was just lots of dots.
Yeah.
And there was no 1 in 20 provision.
Correct. Yeah, that has not
How
got
does
inclination.
that work?
Yeah.
Is
So-
1 in 20 not always used?
To make that a sleeper that's only a vertical sleeper that you may use in S&C or vertical track. Some railways,
Right.
not many,
So-
do just use vertical
Right.
inclination.
Okay.
But for us, as a normal sleeper, all our sleepers are inclined 1 in 20,
Yes,
so we need
of
the
course,
inclination
yes.
the same as what we've got on the other ones. So they've got to work that in. At the moment they've got the flat surface and they've just put houses on it and a pad, And you saw the other version, which was the Roslo version, that had the
Yes.
1 in 20
Yes.
slope in there,
Yeah.
and concrete sleepers have got a 1 in 20 natural slope, which
Yes,
you've seen.
yes,
You see that sort of
yeah.
gradual dip in the middle. And if you look at some of the old designs where they dip in, and they also, some of the versions in France and Europe, they go slender inwards and come out like a bow tie. So that's not that sort of exaggerated, but they do have that shape, and that's sort of a shape that we would sort of, rather than just doing a pure cylinder with a couple of beveled edges, maybe that's something we can replicate as well. That Cemex are looking into.
French would be more elegant, wouldn't they?
Okay,
Okay, I think,
Malcolm.
that's a couple of
Just
questions.
one more, because
Definitely,
the
yeah.
component that you haven't mentioned tonight is rail.
No, I
And
left it out.
now, I'm not going to go into a huge
Yeah.
with it, but if there is a criticism anywhere about this whole process of recycling and so on, it is the rail. Seems to be.
Yeah.
The great store was placed many years ago in. You try to reuse as much rail as you possibly could, and we had procedures in place for inspection, for treating the rail, all those sorts of things, even re-welding them into new CWR,
Yes.
recycled CWR and so on. There is so much rail lying about all over the place at the moment. And wherever you go, a new siding or whatever it may be that's going in has new rail put in it. Why
Yeah.
on earth are we doing that?
Yeah.
Why
Why are we
isn't
using
the
serviceable?
recycling being done? We seem to get the excuse, and it is an excuse, not a reason. The excuse is we haven't got enough facilities to be able to go and pick the old rail
the
up,
old rail
which
up.
is a load of rubbish. quite
Yeah.
frankly.
Yeah.
It's just will.
And they need to tie in with So sleepers is a sort of example, serviceable sleepers is another example of that. Where people start to see, and actually rail is our worst carbon, offender. It's 42% of our track form in CO2 is rail. So it's the worst thing. So greener rail is a good way to reduce that. But cascading has got to come through, or reprofiling and selling it off. There's companies out there that, like you say, you can give them 60-foot rails, they weld it back up again, and they'll tie the top up and sell it off to someone else and make money from that. Why aren't we doing that? I think it's not having the resources in place to do it. You're right. We probably do need 1 or 2 more trains to pick up the amount we need, but we're going to need that in the future. If we're saying we're having green steel, we're going to have to also give our steel back to British Steel or High End or wherever it's going, so they can feed that electric arc furnace with our steel rather than using virgin iron ore. And I think that's our problem. But fragmentation doesn't help. Having little different areas doing different things, and it takes one region to go, I want to do this. Actually, I want to use that rail. I want to use these sleepers. Can I have a recycling ballast facility in my yard, please? So people are starting to ask these things now, saying, actually, can we be self-sufficient as a region and we use rail, concrete and stuff? And maybe there's a clause that says nothing comes in, it all stays in. We just have 10%. Those sort of things. People are starting to look at that now. I mean, it's a long way away, but they're saying, how far can we go with, how much life have we got left in the steel? Do we, if it's 15mm head worn and the side worn, that would last in a siding for another 4 years. It's not going anywhere. Put it in. I think it's the will, changing behaviours, and that will soon come. We'll have to start doing that just because we haven't got any rail.
But it can still follow the cycle from the sleepers, where you say they go around the cycle, the rails can come out, they go back, because steel mills love rails. Steel mills absolutely love it as scrap because it is so consistent.
The premium is premium grade for them. I met this guy in Intertrans that gets rail, and out of it he creates bare balls that he uses for shotting. And he creates all sorts of shapes and things out of it and recycles from steel because he knows exactly what's in a piece of rail. You've got that quality, like you say, consistency.
They're always looking. You've got these people all over the place looking for 40,000 tonnes of scrap rail. It doesn't exist anymore. Years ago, there used to be massive lots of rail that they'd send off to we chop it into 1 metre lengths, and they know by putting 1 metre length in, they've got X amount of carbon, X amount of nickel.
That's right. And we used to, on Underground, everything was chopped up into small man-handled lengths that you can sort of take up an escalator and stuff like that. It's a lot of steel. And we should make the track renewal contractors or projects. If you put new rail in, you have to recycle the old rail. So that's.
They need to give you like credit, saying if we give you 4 miles of rail new renewals, we want.
There could be a cost
saving rail back.
There could be a cost saving. There could be some sort of cost or carbon initiative there.
Obviously, the last time I did renewals on the southern, it was a case of they never allowed in the resources on the trains and the staff to go around on a Sunday evening to collect the rails and take off site. They just say, we'll put it up and they leave it for a post-installation item of work that never happens because renewals are always overspent. And it just get left there.
It does,
So there is probably 40,000 tonnes of rail out there in bits, but no one's got the money to remove them.
And for cast manganese crossings as well, Malcolm. Roslo are now doing recycled cast manganese crossings, so give cast manganese back, put it back through. Again, consistency, they know what's in it. 13% manganese, they'll do the checks, but they'll put it back through, and they're quite expensive, so and they're quite high carbon. But okay.
Anyway, we've gone 7:30.
I know
we'll be here on that.
Greeting into our
Darren, thank you very much. It shows the level of conversation that's followed. There's a lot to discuss there, and we could go on for a lot longer. So, thank you very much. Malcolm, could I ask you to deliver a vote of thanks?
Yeah.
I'd have to stand up and talk to you again. You see.
I'll sit down.
It's always a pleasure for you to come and talk to us, Darren. Tonight's been absolutely no exception. Really good. It's actually very pleasing to know that what you're doing at the moment and what Network Rail are doing in connection with this recycling projects and so on, they're all very real, they're all very meaningful. They do actually matter, and they do matter for our industry as well. And it's great to see that they all going forward. Your enthusiasm, and I'm sure the ones that the people who are working with you, and especially people like from Southampton University, who have a genuine interest in making things, giving you the results that you need to be able to make your proper decisions and all this sort of thing. It will all work. I'm sure it will. It's been really very interesting tonight, and I'm really pleased that things are developing in the way that they are doing. Anyway, join me in thanking Darren.
Thanks for that.
Right, Richard, next meeting please.
Well, the next meeting is down here. This is going off down to the West Country, which will be rather nice. The talk is Resilience and Restoration, Story of Two Railways in Devon. So you can guess that resilience and restoration must be about the seawall at Dawlish, etc. And the other railway is about the Oakhampton branch. So a bit of Great Western, a bit of Southern,